formula for volume, except they gave it to you. Lazy bums. Just kidding, not lazy. I come back to number 52 and just, because we are going to grade number 52, do this in order as we do them. Hence 50, then 52, then 54. Sorry guys, give me 1 second to orient. What was the clue? Slant height of what? 6. And so you looked at your figure. As you looked at your figure, I heard David up here leading his group. A few others of you were like, oh yeah, we figured that out also, that you could use Pythagorean theorem to relate R with H. Not in the related rates sort of way. I mean, it is relating the two. But for our clue. So hopefully you got your clue to B. What are your sides? That's a paw print, by the way. R squared plus H squared is 36, right? Why? Well, because we have this really nice volume formula, and what do we need to do to the volume formula? He is our primary, which means, yeah, we want to get it to one variable in order to be able to, how do we find the max of something? We need the critical numbers, and then we need to think about endpoints and think about whether we need to make a table with the endpoints and the critical numbers, or whether we just need a sign chart to look at the behavior. So all of this was a clue, whatever those descriptions. Here this is, what are the dimensions? What are we trying to find? I'm guessing R and H. Is that okay? If we find R and H, we have the dimensions. We don't normally talk about sizes of cones. And then all of this was saying get V as a function of R, like that. I might rebel and not do what letter A told me. Why? Does anybody see why I might want to get it in terms of H, it means instead of in terms of R? Because it's R squared, and what can we solve for really easily? R squared, right? I don't know. I'm going to be lazy, and I'm going to go ahead and say, forget getting it in terms of R. I'm going to get it in terms of H. Sure. If you got it in terms of R, I'm very proud of you. You would have had a square root in there somewhere and would have had to do a product rule. Anyway, does the book always go the easiest way? Does CalcChat always solve something the way you should or would? No. Word to the wise, yeah? So V is equal to, what do we got? 1/3 pi 36 minus H squared times H. Why is it so much nicer this way? If you had H equals the square root of 36 minus R squared, you would have had to do the product rule. But what can we do before deriving? Yeah. Since there's no square root, look at us. Actually, we could keep going if you wanted. And we would end up with, 36 over 3 ends up being 12, right? 12 pi h minus, and then we have 1/3 pi h cubed, I think. Anybody tracking and agree with my math? Cool. It's a cube. Thank you, thank you, thank you. I said it right and I wrote it wrong. Struggle. So now what are we supposed to be doing? Oh yeah, we're finding the max, right? So then we want V prime. 12 is just a constant, obviously, but what is pi also? Just a constant. So what's the derivative of h? 1. Since we got volume as a function of h, we're just going to get V prime of h. No big deal, no extra details. This cone is expanding or falling. There's not water in it that's expanding or falling. Or I should say rising or falling. Increasing or decreasing. So we can just say 12 pi, derivative of h minus get pi squared. Yeah? Whole point critical number said equal to 0, no DNEs because there's no denominator. If we subtract the 12 pi, divide by a negative pi, what's 12? We bring down the 3. Power rule. Sorry, subtracting the 12 pi by the negative pi, that's 12. And I think we get h is equal to plus or minus square root of 12, but wait, which one does not make sense? Yeah. Speaking of making sense, shouldn't we think about endpoints for a second? For our endpoints, let's think about domain. How small can h be? Well, 0, but it can't be 0 or there wouldn't be a cone. How big can h be? Well, let's say we used all of this on h. So r didn't have any, which isn't practical. But what's the biggest that h can be if r isn't using any of this? 6. So h can go up to 6, but not including 6. H can be 5.99999, and r can be 0.000. Well, anyway. Wouldn't be very practical. It would be a very impractical cone, but it's possible. to still get this to be true and have a really weird, tall, skinny cone. So anyway, h is between 0 and 6, but not endpoints. So if not endpoints, we're not doing a table, so what are we going to do? Sign chart and make sure everything works out just fine. So we have v prime and we have v. We have our square root of 12. Can anybody give me a something approximate-ish of square root of 12? Oh, simplifying. That's true. AJ is making it look nicer. So 2 square root of 3 might help a few of you guys. But why? Anyway, 3 point something, something, something. Can't we plug into 1? Cool. So plugging into 1, we end up with pi minus pi, 36-ish minus 3-ish. Yep, that's going to be a positive. And then if we plug in something greater than, like 5, 25 pi, 12, 25 pi, yeah, that's going to be a negative. And work with what we think it should be. I see a max. You see a max? Cool. Volume is maximized at h equals 2 rad 3 centimeters? Oh, it didn't say. Okay, whatever. We just have to leave it because they didn't tell us the units. We could just say units, I suppose. And r, wait a minute, we needed h and r. Remember, don't we have that clue up here that tells us how they're related? So we can go ahead and I would take the root 12. That sounds easier to me. Plug it in, plug it in. Back to our clue. Root 12 squared is 12. 36 minus 12 is 24. Square root of 24 to get r would be 2 root 6. Something like that? You guys agreeing? Dun, 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 dun. Dun, dun. How are we doing? Is there a procedure to optimization? Ah, stop. Don't use the word optimization. Whatever. It sounds hard. What are optimization problems? Just the ones that have what idea in them. Find the max or min. Oh, critical numbers. If there are endpoints, use those too. Dun, 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 dun. Don't forget the clue. Technically before the critical numbers. Okay, so open up to your homework from over the weekend. 52 and 54. Let's go ahead and grade those two evens real fast. I'm going to actually work through them because I love the multiple choice and the long answer idea, and this is also the AP prep. So you guys have had a chance to play with it. You couldn't grade it. So let's see what's going on. Number 52. You guys can actually grade these with me step by step. What is the maximum area? Please. You guys realized area was the primary, right? I have a right triangle with a hypotenuse of 12. That's my clue. Oh. My clue is just h equals 12. Okay. Maximum area of a right triangle. Okay, better draw a picture. H, that's that guy, right? We know that guy's 12. Who don't I know? Well, what do I need? A equals 1/2 b times h. So that must be my b. Whatever, I don't know this guy either, c, but do I need him? Because I can just say A is equal to, well, I can take my clue and say, okay, whatever. Plug it in, plug it in. 12 over 2 is 6. 6b is my area. I can go to my A prime. Okay, A is a function of b. Let's just go. 6. Huh? Good. I said h for height. No, I didn't. I said h for what? Ooh. So is this h the same as that h? Careful, when you're labeling things in these problems, you might say like, oh, h, hypotenuse, but not, there's another h. Let's make sure that all of your variables, if there's an h here, you can't use him over here. So we do need to say that c is equal to 12, which makes things a bit more complicated. Do you guys see how that's confusing anyway, though? 6 can't equal 0, so I would have no critical numbers. So let's back up just a little bit, sadly all the way back here, to say I can't use h for hypotenuse. Maybe we should have drawn the picture first. I think actually in our notes it says to draw the picture first. So maybe we should do A and B and C. And then we can say hypotenuse C is equal to. 12? Which means what else is equal to 12? Yeah, or I could, ooh, that's a good idea, Ryan. I was going to do square root to get c by itself, but it might be easier just to say a squared plus b squared is equal to 144, right, guys? Oh, that's cool. We'll use that in a second. Now, how do I write my area formula in terms of my picture, so that way everything's all united? Area equals 1/2, who's my base? A, times my height. Cool. I want a prime. Can't yet, so how am I going to use my clue? What do you guys do? Solve for a or solve for b? Sure. So a is equal to the square root of 144 minus b squared. Now I can go ahead, oh, there's a square root. Yep. We're actually going to see something today. In that very final example, the one type of problem I said you guys shouldn't do that had to do with closest and farthest and closest, that actually gives us a shortcut to deal with lengths or amounts that have a square root. But give me a second. Let's go ahead and solve this the traditional way, because that's probably what you guys did, right? Meaning, solving for the critical numbers, derivative, what rule do you have to use? All right, let's go product. Some of you, though, should have probably rewritten this for your brains, yeah? It's going to be to what power? Good. So I have my second defect. Isn't that just 1/2? And that's square root of 144 minus, don't you love yourselves? Rewrite it in a way your brain knows. So second d first, that's just 1/2, plus first d second, 1/2 b times, bring down the 1/2, make this guy a negative 1/2. Right, bring down the 1/2, make it a negative 1/2, but don't forget your prime. It's negative 2b. One of those 1/2s goes away. I have a b squared on top, a negative b squared on top. Come on, you guys have done this long enough in homework 19a, homework 20a, homework 21, and now in this chapter as well. What do I do? Critical numbers. Common denominators, good. Thomas, that's what you meant by multiply, right? The square rooty dude. A square root squared cancels out, right? So I get 144 minus b squared all over my common denominator. Whole point was critical numbers, right? This one's b equals plus or minus 12. This one, b equals, 144 minus 2b squared. Negative 144 divided by negative 2 is 72. 72 square rooted. Did anybody get to plus or minus root 72? No acknowledgement whatsoever. How many of you guys figured out that the area of the triangle is 1? If you figured out that the clue had to do with a squared plus b squared is 144. Keep your hand up if you somehow tried to plug in the clue to the area to get something to derive. Keep your hand up if you use the product rule to try to derive. Keep your hand up if you got common denominators. Okay. Last two. Rachel and Patricia. Anybody 72? Okay. Oh, yeah, I could have kept going. Rachel simplified. Patricia said, yes, she got 72. Rachel said, isn't 36 going in there twice? So she went ahead and wrote it pretty. You guys agree? Cool. What are we actually going to worry about? Just the top. Why? Why can't the bottom exist? What haven't we thought about yet? Domain. How low can B go? Well, to be practical, he can't go to 0, right? And how high can he go? What's my clue? I have to get to 144. What if we use everything up on B and nothing on A? B would be 12. B can't be 12. To have a triangle, A has to be something. But B definitely can't go beyond 12. What does that mean? Forget those guys, they're not in the domain. And forget the negative guy, because that doesn't make any sense for an actual triangle. Are we good? Cool. So what am I going to do, since we don't have endpoints? Yeah. So I have my 6 root 2 or my rad 72 and plug into A prime to get A. And just to save on time, because you guys should do this, if everything worked out well, and I already double checked with a couple that we're on the right track, we're trying to maximize or minimize. Oh, sorry, it's right over there. Maximize. If all well, which I'm guessing my 2 girls it does. I get a max. Wait a minute. What are they asking for? We didn't do that, did we? What is the... They just want A. Oh. Who did I just solve for? What I can say is B equals 6 root 2. We can go back and find H, right? Well, sorry. We didn't call him H after all. But we'd have 144 minus 72. Wait, that's 72. Square root of 72. Oh, they're both the same thing. Okay. 6 root 2. So then we have to plug into our area formula to solve. So 1/2 of root 72 times root 72 will be 72, and 1/2 of 72 is, double check me girls, 36. Dun, 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 done. Final answer, 36. Make sure you mark that down with a colored pen, because we're not going to grade it later when we go over this, aka the evens. Wait, not 72, 36. It's C. Choop. All right, what was going on number 54? What do you guys see? Ooh, a rectangle. Bounded by, isn't that a parabola? A parabola's been going up 25, which means he comes down to -5 and +5. So there's a rectangle somehow inside. What size rectangle? I don't know. I just said a rectangle. There's a rectangle inside my parabola. Some of you remember something like this last year in pre-calc. What's the picture? Probably not the math. Huh. Chapter 1 or chapter 2? Bounded by the x-axis. Yep, that's a boundary. And by the curve. Yep, it can only go up so high until it hit the curve. Okay. Dimensions. I guess length times width, yeah? So where are the dimensions? We can do length and width. We'll come back to that in a second. Maybe we'll use, maybe we won't. Rectangle, so that who is a max? Area. So I have area is equal to length times width. We'll get back to that in a second. Huh. What's my clue? Do you guys see an equation hiding up there? Oh. Hey, look, it's a y. Wait a minute. But I don't have x's and y's. Okay. Here's where last year comes in. Guys, doesn't this hit add an x and add a y? Whatever the rectangle is, that's an xy, that's an xy, that's an xy. X is how... Yeah. So 2x, 1. So I can rewrite area to be 2x times y. Oh, life is easy, right? You know what I'm going to do. What am I going to do? Go substitute. Make it what I want it to be. I'm going to rewrite because ain't nobody got time for that. True? Everything is for the purpose of critical numbers, yeah? 50 over 6, which is 25 over 3 and square rooted. So x is equal to plus, no, not minus, right? That's impractical. 25/3. Technically, if you think about it, if there's a positive point, there's also a negative point. So all we need is one point to define both, if you want to think about why I crossed out that negative. What are my endpoints? Yeah, the biggest smallest is -5, but is there a rectangle if we're actually at either of those? No. So, then I make a lot of these. 25/3 is what, 8-ish, and 8-ish square rooted is something like 2 point something-ish. Yes, we could make that 5/√3 or 5√3/3. I'm just being lazy. We can do A prime. We can do A. So that's point something. Well, actually, if you guys want to think about it, x can go between -5 and 5, but since we're only looking at the right-hand side, I guess we could just look 0 to 5. Because if we have a point between 0 and 5, it defines the other point at the same time. So maybe we'll change this to 0 to be easier. Let me plug in like a 1. Yep, that's a positive. Let me plug in. So I have my zoop, I have a max. Was that the point? Yes. That was the point. And they're asking for the dimensions. So therefore, if x is equal to 5/rad3, just simplifying, y is going to end up equaling, that's the square root of 25 squared would be 25 75 50 I think y is equal to 50 25 after the square rooty, that'll be 75 50 yeah. Which means my rectangle, the dimensions are 2x, so 10 by 1y. And they didn't tell me what the units are, so that's okay. That'd be the max rectangle. What's letter B? Oh, letter B. That was just letter A? What's letter B change? I'm not going to... Sorry, but go ahead, AJ. What's it change? What's my clue? What change? 2x plus 2 height, 2 length plus 2 width. And we can actually steal and use the exact same clue that we used up above. You guys see I'm going to do a ... Rewrite, derive, critical number. We'll check the final even answer when we get there. Sound good? Okay. At this point, we're going to go back to our notes. And we're going to grade optimization the rest of the homework tomorrow because we're running out of time with chapel day. And that's okay. We're going to introduce section 3.7. There was one problem we didn't get to. Has to do with closest and farthest. You guys should have already done your Google Classroom submission this morning without doing the closest or the greatest. Sorry, closest, farthest, greatest distance, least distance. We've left this one off. This is what we're going to actually do homework spiral together, I think, tomorrow. But we're going to grade the rest of homework also tomorrow. But right now, let's at least get the idea of the next section. 3.7, there we go. Differentials and linear approximation. Differentials and linear approximation. There's a couple things in this section, a couple big ideas. We're going to take a couple days on it. Remember, make friends with the BC kid. Preparation for this final quiz. Starting in this section, they should ace it. Optimization, remember I told you they kind of have a bad stigma in their mind because they focused on the optimization word and didn't focus on, it's just a max-min problem, whatever. But tangent line approximation, they should all be good on, as well as differentials. Here's the main idea. If you guys look at this parabola, let's imagine the parabola was not there. Let's imagine, just for a second, the parabola was not there. Could taking a few little baby tangents, making little baby tangent lines and graphing them, could they kind of show us what the graph is? Yeah, you could kind of like skim one tangent pointing to the other tangent, pointing to the other tangent, pointing to the other tangent. Now, is this always a perfect indicator of what's going on? No. And if we had made these tangents much bigger, like this one, for instance, we would have gotten way off track. But tangent lines are pretty good stinking approximations, really close, for baby tangents, really close to the point of tangency. Some of the keywords that you're going to see where you need this process is not just making a tangent line, but using a tangent line. Use a tangent line to approximate. Whenever they say use a tangent line, they're referring to the process I'm about to show you. Whenever they say something about local linear approximation, this one's a little tricky because it doesn't even say tangent, but when they're talking about local linear, local close to a point, linear, the line close to a point, they're talking about a tangent line. They could also say something to the effect of, I've seen directions say linearization. But all of this points back to the idea of, I guess you could also say tangent line approximation, but that puts some of these other words together. Using a tangent line very close to the point of tangency to approximate. But you're not going to actually have to figure out what the error is specifically, even though you could. Just the idea is a tangent line does a pretty good job when it's close, of being close to the actual function. So this is our f of x, our actual function. So our f of x values are the exact, or are the precise, they're the exact values. And then we could call the y values of this guy L of x, which are going to approximate f of x when you're really close to this point. So y equals f of x is going to be the exact value, function value, and we're going to use the tangent lines y as L of x to approximate f of x. How do we do that? Well, without having tons of time left, we're going to go ahead and go back to that forever that we did a long time ago, where we have y minus f of c equals f prime of c times x minus c. Some of you guys would rather use a's, and that's okay, I don't care. B's, that's okay, I don't care. But the idea is given the point of tangency, which is going to change depending on what they're asking us to approximate. But whatever point of tangency works well for what they're asking, we're going to find the tangent line at that point, the one that we know c and f of c perfectly. And then we're going to go ahead and we're going to get y by itself by moving f of c to the other side. And then we're going to find whatever they want. Approximate the value requested. X equals a. Find L of a, which is going to help us approximate f of a by plugging in, still using the point of tangency. We have to use the point of tangency. But all that changes in order to make this approximation is we just plug in x is a. And then we can solve all of this. And this is the way that you guys will be able to get a pretty good stinking approximation for something like the cubed root of 29, square root of 8. Because we know something really, really close to the square root of 8 and really, really, really close to the cubed root of 27. Kiddos, thanks for the extra 50 seconds. Get out of here. Get going to period 2. Bye. Maybe even the cubed root of 126. What is that? 5 point? Ooh, we'll get better than that tomorrow.